Hello everyone, my name is Teacher Glenn and welcome to my discussion of organizing data. In today's discussion, we'll be talking about problem sets related to ordered array and frequency distribution table under organizing numerical data. Just a quick recap, we have talked about organizing categorical data, dealing with summary table and contingency table in my previous video lecture. So let's move on to our problem sets. We have the first problem set. Construct ordered array given the following data from a sample of n equals 7 midterm exam scores in accounting. So as you can see, there are 7 row score or 7 set of data in which we need to arrange this in ascending or descending order. To do this in Excel, simply copy this set of data and let's place it on our answer area, and we go to sort and filter, click custom sort, click continue with current selection, and go to options, select sort left to right, press OK, and don't forget to click on sort by, and we are referring to row 7 because row 7 is the location of our set of data, and we need to, or we'd like to arrange this from largest to smallest. Click OK. There you go. This is now arranged in an ordered array from highest to lowest, where we can see that the highest score is 94 and the lowest score in the midterm exam is 63. The median as well is 71. So that's problem set number 1. And I'll proceed to problem set number 2. Problem set number 2. The GMAT score from a sample of 50 applicants to an MBA program indicate that none of the applicants scored below 450. So we can see that on our first sentence. We have 50 applicants, meaning we have 50 sample on our, or on the summation of our frequencies. Next sentence. A frequency distribution was formed by choosing class intervals 450 to 499, 500 to 549, and so on, with the last class having an interval from 700 to 749. Okay, so we can actually set our frequency distribution based on our second sentence. So we start with the lowest, which is 450 to 499. Now to complete our class interval, we need the class size, and to do that, we simply subtract or get the difference of the upper limit and the lower limit, and we add 1. So the difference of 499 and 450 is 49 plus 1, that would be 50. So to complete our class interval lower limits, press equals on our second group or second class interval, and then we choose our lower boundary from our first group plus our class size, that would be 50. Then we simply copy the formula, and we were able to complete the lower limits of our class interval. And to complete the upper limits of our class interval, we go to our second group, press equals, copy the upper limit of the first group plus our class size, which is 50. That's 459. So you notice on our second sentence, the class interval is from 450 to 499. That's correct. The second group is 500 to 549. That's correct. And our last group should be 700 to 749. Now, if we copy the formula on our upper limit of the second group, we end up with the correct last group, which is 700 to 749. Now we proceed to the next, or to the last sentence. 2 applicants scored in the interval 450 to 499. So the frequency on the first group would be 2, and 16 applicants scored in the interval 500 to 549. So the frequency on the second group is 60. Now we don't have other information on the remaining groups, so we now proceed to our first question. What percentage of applicants scored below 500? Below 500 is pertaining to the first group. So to get the percentage, we now proceed to our relative frequency by simply dividing the frequency of that group or the first group and the total sample, which is 50. So that would be the relative frequency of the first group is equal to, press equals, click frequency and divide by 50. You simply type 50 so that this will go on with the formula for the rest of the relative frequencies. If I pull this formula or copy this formula, the relative frequency for the second group would be 32%. So the answer for letter A, the percentage of applicants who scored below 500, that would be 4%. So this one is 4%. Letter B, what percentage of applicants scored between 500 to 549? It is referring to the second group of data, so that would be 32%. That's 32%. Letter C, what percentage of applicants scored below 550? As you can see, 550 is located on the third group, so below 550 with all the would mean that it's referring to these upper groups from 550 or from the third group. So to get that percentage of applicants who scored below 550, we'll be needing the listed cumulative relative frequency. To get or to compute it, we have the first group, that would be 4%, and the second group would be the sum of these two. So that's equals plus this cell, so that would be 36%. So meaning the applicants who scored below 550, referring to this group, be 36%. So that's 36%. Now last question, what percentage of applicants scored below 750? Now 750 would be referring to all this group. Now all this group should have a total of 100%. So the answer here would be simply 100%. There you go. So we have completed problem set number 2. Now proceed to problem set number 3. A set of data has values that vary from 11.6 to 97.8. On our problem set number 3, the first sentence already mentioned the range, which is from 11.6 to 97.8. Question number 1. If the values, or if these values are grouped into 9 classes, indicate the class boundaries. So on this question, it is already asking that we need to create a frequency distribution table using the information that we have on this problem. So let's compute for the range. The high score would be 97.8 and the lowest score would be 11.6. Now the difference of these two is 86 points. And for question number 1, the values are grouped into 9 classes. It already mentioned that there are 9 classes, so our class interval is 9. Indicate the class boundary. So it's asking us to compute for the class boundary. But to do that, we need to complete the class interval first. This is the class boundary, where we will refer it to our class interval. So we need to create the class size, or compute for the class size. So the class size would be the quotient of the range and the class interval. So that would be equals, this is the range divided by the class size, that's 9.6. Notice that this is under decimal value because our range or our data is in decimal place. 1 decimal place to be exact. Now, the suggestion is to round this to the next odd number. So we will retain the decimal value, but we simply add this or round this to odd number. So 9.6 becomes 9.7. I'll be choosing this as my class size. So let's start with the class interval. We start with the lowest score, that's 11.6. we complete the rest of the lower boundaries by adding 9.7 in every cell based on the first group lower boundary. So that would be equals. We are now working on the lower boundary of the second group. Equals M3. M3 would be our basis, the lower boundary of the first group, plus 9.7, that would be our class size. So we drag this formula. There you go. We have the complete lower boundary of the class interval. And the upper limit of our first group, this would be equals our lower limit plus our upper limit 9.7 minus 1 unit, which is 0.1, because we are dealing with one decimal place. If this is a whole number, then that would be 1.0 or simply 1. So notice that 21.2 and 21.3 are succeeding numbers. 21.3 comes next to 21. So that's correct. The upper limit of our second group, this will be equals the upper limit of our first group plus, this time we add our class size, 9.7. Then copy the formula. There you go. We were able to complete our class interval. Now you might be asking, why is it that we have 98.8? Well, this is okay in presentation of data, as long as you have your lower or your first group starts with the lowest score and your last group contains the highest score. Now we work on the class boundary. So since this is in one decimal place, our class boundary would be in 2 decimal place. So we start with the upper limit of the class boundary equals the upper limit of the class interval. We add 0.05. So from 21.2, it becomes 21.25. Notice that this 21.25 is between the upper limit of the first group and the lower limit of the second group. That is the boundary between these two groups. For the lower limit of the class boundary equals the lower limit of the class interval, and we subtract 0.05. There you go. You can simply copy for the rest of the lower limit of the class boundary, and the same with the rest of the upper limit of the class boundary. So notice this should be the same. The upper limit and the lower limit of the first and the second group. Similarly with the third or the second and the third, and for the whole pairing of the class or for the frequency distribution table. So going back to question letter A, if the values are grouped into 9 classes, indicate the class boundaries. So this would be the class boundaries. And letter B, what class interval width did you choose? This class interval width is referring to class size, where we made the use of a formula for the class size, the quotient of the range, and the class interval. For letter C, what are the 9 class midpoints? Midpoints would be referring to class mark, simply the average of the lower and the upper limit for any of these two, the class interval or the class boundary. So simply, we add these two, the lower and the upper limit, divided by 2. We can choose class interval, we can choose class boundary, it doesn't matter, your result will be the same. If I do that, equals, let me add the lower limit of the class boundary and the upper limit of the class boundary of the first group and divide it by 2. Make sure you enter your correct formula so Excel would be able to read and execute the proper formula. So that's 16.4. If we drag this, we end up with the same value for the rest. Or another way to do it, a simpler one, just simply look for average, then you can simply choose this location of the upper and lower limit. It doesn't matter. Excel will only read the numbers. So average equals, so that's 16.4. Do the same thing then. You get the same result. So there you go. We are done with problem set number 3. Proceed now to problem set number 4. A manufacturing company produces steel housings for electrical equipment. The main component part of the housing is a steel through that is made out of a 14-gauge steel coil. It is produced using a 250-ton progressive punch press with a wipe-down operation that puts two 90-degree forms in the flat steel to make the throw. Distance from one side of the form to the other is critical because of weatherproofing in outdoor applications. The company requires that the width of the through be between 8.31 inches and 8.61 inches. The widths of the throughs in inches are collected from a sample of 49 throughs as shown below. So notice that the question is an application of what we are doing right now, organizing numerical data. So this is a company that requires an exact width of the throw between 8.31 inches and 8.61. So they collected 49 samples as shown below. The first question now, construct a frequency distribution and a percentage distribution. Letter B, or second question, construct a cumulative percentage distribution. In my solution, I'll be combining these 3 in one table. For others, you can actually separate this into 3. In my case, I just simply combine them just to show how you can utilize this frequency distribution table in presenting data. Now, question number 3, what can you conclude about the number of throws that will meet the company's requirement of throws being between 8.31 and 6.61 inches wide? So let's go to the solution. This is your row data. Capital N is 49. And I also included the steps here just to remind me on how to construct my frequency distribution table. So first is to find the range. Second, determine the class interval. And third, compute the class size. So my range is the difference between the highest score and the lowest score. To do that, I'll use my formula, maximum enter, and my maximum value is 8.498. Notice as well that the row data or the information comes in 3 decimal value. So all of our solution and table should also come in 3 decimal place. And I'll proceed to our lowest score. So we choose our formula minimum. Press enter. So there you go. My highest score is 8.498. My lowest score is 8.312. The difference is in 3 decimal place as well, 0.186. Now my row data, capital N, is 49, such that my class size, that would be the square root of capital N. To do that on my Excel, I'm going to look for SQRT as the square root, and I'm going to click the location of my capital N. So the square root of 49 is 7. Step 3 is to compute for the class size I. It's the quotient between the range and the class interval. This is equals the range divided by your class interval. So that's 0.0266. Now again, since our row data is in 3 decimal place, our class size should also be in 3 decimal place. And a suggestion, always round this to the next odd number, so that if I round this to 3 decimal place, it's already an odd number, so That's 0.027. That would be my class size. So to start with my class interval, I'm gonna start with the first group and start with the lowest score. That's 8.312. That's in 3 decimal place. If I proceed to my next group, lower boundary, I'll simply add the lower boundary of the first group plus my class size, which is 0.027. Then drag the formula down. I'll copy the formula. I have completed the lower limit of my class interval. I proceed to the upper limit of my class interval. This is now equals the lower limit plus my class size 0.027 minus 1 unit of this, that would be 0.001. So notice that 8.339 comes after 8.338. Complete the rest of the upper limit. This will be equals upper limit of the first group plus class size 0.027. And copy the formula for the rest of the upper limits. So I have completed up to 8.527. I made a mistake here. This shouldn't be here. Let me remove this. There you go. So it should only be up to the 7th group. 1, 2, 3, 4, 5, 6, 7. Just to make sure, let me just put some code here. There, so I have 7 groups. So my last class interval should be 8.474 up to 8.500. Okay, so notice my first class interval contains the lowest score, and my last class interval contains the highest score. To complete my frequency, well, I have a shortcut here using COUNTIFS, and I'm going to show you another shortcut using the data analysis of Microsoft Excel. So let's start with, so that would be equals COUNTIFS and the criteria range 1 would be this set of data. My criteria, let's go to class interval, the first group, that would be greater than 8.311. So I have placed greater than 8.311 to make sure that this 8.312 is included on the counting of the frequency. Then I go to my criteria range 2. Then criteria 2, it should be less than this lower limit of this second group. So that would be less than 8.339. Then click OK. So there are 3 frequencies for the first group. Now, before I copy my formula, let me just lock this criteria range, for it contains the row data, or the set of row data we need on our formula. Press enter. There you go. Drag it down. Now update the second group. The range should be from greater than 8.338, but less than 366. Okay, so again, the range is greater than 8.338, but less than 8.336. Press enter. Number 3. Update the third group. The range should be greater than 8.365, but less than 8.393. 8.393. And for the next group, it should be 8.392, and this should be 420, 8.420. Then the fifth group, this should be 8.419, and less than 8.447. Then the next group, sixth group, be greater than 446, 8.446, less than 8.474. Then the last group, greater than 8.473, 8.473, less than, say, 8.501. Okay, so it shows that the total number of my frequency is 49, which is the same as my raw data. So I'm pretty sure the frequency is correct. Now let's get the class mark. That's midpoint, the average of the lower limit and the upper limit. So equals. Let's use the formula average. Click this area. It will only compute for the numbers. And OK. The class mark is also in 3 decimal place. Now the relative frequency. This is equals your frequency divided by total number of row data. That's 49. Already in percentage form. Sometimes if this is in decimal value, you have to click percentage icon. Then drag this. The total should be sum is 100%. There you go. You can also create a less than cumulative relative frequency. This is equals 6%. This is equals 6% plus 6%. Then drag the formula. There you go. For this presentation, I would like to show class boundaries as well, although it's not necessary, but just to show you. So let's work on the lower limit of the first group. This is equals your lower limit of the class interval minus, this should be in 4 decimal place, 0.0, and that's 0.0005. Okay, so notice that the class interval is in 3 decimal place, your class boundary is in 4 decimal place. Similarly with this class problem set number 3, the class interval, all the class interval are in 1 decimal place and the class boundary is in 2 decimal place. We go back to problem set number 4. There you go. And the upper limit for the class boundary equals the upper limit of the class interval. We now add 0.0005. There you go. So notice that the upper limit of the first group and the lower limit of the second group should be equal. Same with the next pairing, the second and the third group, and the third and the fourth up to the last pair of the last groups. So we have the 6th and the 7th groups upper limit and lower limit should be the same. Okay, so there you go. I'll show you another way of creating the class frequency. Let me show you how to use data analysis. So click data analysis, and we can go to histogram. Now, if this is not appearing on your Microsoft Excel, you might click File, go to Options, and go to Add-ins. Click Add-ins, and then under Manage, click Go, and you need to click or put a check mark on Analysis Toolpack, or just the first two, Analysis Toolpack, and click OK. In my case, it's already there, so I don't need to redo it. You only do this once. Alright, so let me show you. This is a quicker way of creating your frequency distribution table, and also a way to create the frequency or the histogram. So let's start with data analysis. Click histogram, click OK, and we now go to our input range and bin range. Now, our input range would actually ask the set of our data, the raw data. So input range is our raw data, and then our bin range, this is the upper limit of the class interval. So let's look at the class interval. The upper limit is this. Then we look for the output range. No labels. I did not include the labels. I checked the chart output first. I'm going to show you the use of that later. So let me locate my output range just beside this frequency. So I'll click this area, and let's see the result, output range, and there you go. So notice the frequency is automatically counted. Okay, look at this. I'm showing a difference in this too. Let me check. Okay, so I made a review of the difference why I have 13 on the frequency of the fourth group, and 14 using my COUNTIFS. Okay, I actually did 2 here. This one, the second data analysis, is using the boundary. I made use of the upper limit of the class boundary, and this one is using the upper limit of the class interval, where I noticed that this one is the correct frequency of the group, and we should realize, or we should use the class boundary instead the class interval. So there you go. So on my next video, I'll be presenting visualizing data, where we could actually maximize the use of data analysis, and what's actually the use of or why is class boundary being computed, and how is this shown in visual form. So thank you for watching. I'll see you on my next discussion.